I am Anil Kumar. Welcome to my series on vectors. We'll discuss intersection of lines and planes in this particular video with the help of three test questions. Question number one here is find the coordinates of the foot of the perpendicular drawn from the origin to the plane 2x minus 3y plus 4z minus 6 equals to 0. Question number two is find the coordinates of the foot of the perpendicular drawn from a point minus 2 minus 8 6 to the given plane 4x minus 3y plus 5z plus 4 equals to 0. Question number 3 is find the coordinates of the point that produces the minimum distance between the point P 1 minus 3 1 and the line xyz equals 2 2 3 minus 1 plus t 1 minus 3 minus 5, where t belongs to real numbers. You can always pause the video, answer these questions, and then look into my suggestions. Well, here is the very basic concept. Let's consider the planes. So if I have a plane here, then let's say we have equation of the plane as, let me write down a general equation as, let's say pi equals to ax plus by plus cz, let's say equals to d. So in that case, the normal of the plane is ABC, right? So that is the normal to the plane. So normal to the plane means if that is a plane, let's say the paper which we have then the normal will be kind of like this. Is that correct, right? So that becomes the normal, and this is normal to any line on the plane itself. So there could be any line on the plane. So let's say that's the line. So that becomes normal to the plane, where the line is on the plane. Perfect. So all these examples, we have kind of line and a plane, or a plane and a point outside. So if we have a point here, then we are always looking for a point on the plane which will be perpendicular. Is that clear to you? Now, the normal is along the perpendicular direction, right? Normal means along perpendicular direction. Okay, so let me rewrite this along perpendicular. Is that clear to you, right? That is the concept. So we'll begin one by one. In the first case, we're talking about foot of the perpendicular drawn from the origin, right? So first is drawn from the origin. In the second case, we are considering a point. And in the third case, we have a point and we have a line. Correct? So that is how they are all related. So let's take up the very first question and see how to solve this. So we are saying that find the coordinates of the foot of the perpendicular drawn from the origin. So we know the point here is origin itself, which is 0, 0, 0, right? So I'm saying O as the point, or let's make it Q. So let's say Q is the point 0, 0, 0. And from here, we are drawing a perpendicular to the plane, which is, let's say, pi, which is 2x minus 3y plus 4z minus 6 equals to 0. We need to find the foot of the perpendicular, right? So we need to find the foot of the perpendicular. So that is the particular question. So you could think like this, that we have a plane here. Right? And from the origin, we are kind of looking at a point which goes, let's say that's the origin, and this is the point we're looking for. Is that clear to you? So you could assume that this is, if there's a line here, then the foot of the perpendicular will form 90 degrees angle here. Is that clear to you? So that is how the scenario is. Well, so we could consider a plane here, kind of. Let's say this is the origin. Is that clear to you? From here we have drawn normal to the plane. And this point, we are calling this point as Q. We are calling this point as Q. Okay. So how will you figure this out? Well, what is the equation of this line? What is the equation of this line? Let's say the point here is P. So the equation of line QP will be, we are starting from the origin, right? Which is 0, 0, 0 is our point. So we should not be writing 0, 0, 0, but just to make it absolutely clear, we have this point plus scalar multiple t times, which is a scalar multiple of the direction. And the direction is given by the normal itself, which is 2, minus 3, and 4. So that becomes the line QP for us. Is that clear to you? Correct? So any point on this line will have the x value of 2t, y value of minus 3t, and z value of 4t. So that will be any general point here. Now if the point is on the plane, let's say this is our plane pi, if the point is on the plane, then it should satisfy the given condition. So we'll substitute this value, we'll say 1 in this particular equation, correct? So what we get here is 2 times the x value, which is 2t, minus 3 times the y value, which is minus 3t, plus 4 times the z value, which is 4t, and we'll take 6 to the other side, equals to 6, correct? Now that is 4t minus and minus becomes plus 9t, and that is plus 16t equals to 6. And when you combine all these terms, we get 6 plus 16 plus 4, 20, 29t. So we get 29t equals to 6, or t is equals to 6 over 29. Is that clear? So once we find this, we can find all the 3 points by substituting this value of t in our expression. Is that clear to you? So we get the point. The x value for this is, x value will be 2 times 6 over 29, right? The y value will be equal to 3 minus 3 times 6 over 29, and the z value will be 4 times 6 over 29. Is that clear to you? So multiply, right? So the points here are, so x is 12 over 29, y is minus 18 over 29, and the value of z is 4 times 6, 24 over 29. Is that clear to you? So that becomes the coordinate at the coordinate point P. Is that clear? So that is how we are going to get our answer. So that is the point. Okay. Now let's move on and take up the next question, which is similar. Find the coordinates of the foot of the perpendicular drawn from the point minus 2, minus 8, 6 to the plane 4x minus 3y plus 5z plus 4 equals to 0. Now you can actually pause the video and solve it, right? It is kind of very similar. So we are given the normal here. So the normal here is 4 minus 3, 5. That is the normal for the plane, right? This is for the plane. And we're looking for a point which is minus 2, minus 8, and 6. What do we want? Coordinate of foot of the perpendicular drawn from this point. So it is along the normal, right? So this is along the normal. Correct? So the line in this case, which is, we can say R, will be equal to the given point, which is -2, -8 and 6, plus t times same direction as the normal, which is 4, -3, 5. And remember, t belongs to all real numbers, right? So in the previous case also, whenever we write the equations like this, we should mention that t belongs to real numbers, right? Okay, so that becomes the line itself. And as we did in the last case, a point on this line should be on the plane also, right? So we have a common point between line and plane. And that is the point of intersection. Is that clear to you? So that is what we are looking for, which is this common point. So we're just going to substitute this point here. So we have 4 times. The x value is -2 plus 4t. And then -3 times. The y value is -8 minus 3t. And the z value, this is 5, right? The point is -286, sorry. Point is -2 minus 86, this is 6, right? So we'll substitute this point here, plus 5z, 5 times z is 6, plus 5t, plus 4, right, plus 4 equals to 0. So we have to solve for t. Once we get t, we know what the point is. Perfect. Okay, so let's open the bracket. So we have -8 plus 16t plus 24, minus and minus is plus 90 plus 30, 6 times 5, and 5 times 5, 25, plus 4 equals to 0. Now let's combine the t's and the constants, right? So as far as constants are concerned, we have uh, the constants here as, let's add them up. So we have 4, 30, 24, and -8. So we'll add these constants. So we have, when you add, we get 28, take away 8 is 20, and then 50, right? So we have 50 as the number. As far as the t values are concerned, 16 and 9 is 25, plus 25 is also 50, right? So we get plus 50t equals to 0, and that gives you t equals to -1, correct? So we have the value of t as -1. Now we'll substitute t as -1 and get our points. So the points here are, let's write down t equals to -1 and get the points. So x value is equal to -2, t is -1, right? -2 minus 4, that is the x value, which is -6. The y value is -8, t is -1, so it becomes +3, and that is 5 with a negative sign, and z value is 6, and then t is -1, so -5, which gives us 1, and therefore we're looking for a point which is -6, 5, which is also negative, and 1. Correct? Is that clear to you? So that is how we are going to solve this particular question. Now let's look into the last question here, which is, find the coordinates of the point that produces the minimum distance between the point and the line. So now we're talking about a line in this case, right? And we have an external point. So let us say we have a point here. We are again looking for a perpendicular distance, right? So again, it is the case of normal. Same situation, same method. So we have a point here. The coordinates of the points are given as P, which is 1 minus 3, 1. And the line is given to us. Let's call this line L1. Now we need to find this point. Let's call this point as M. So find the coordinates of the point that produces the minimum distance, means perpendicular, from this point to that. Now any general point M is going to be what? We have to consider that point. It lies on the line itself. So on the line, we have the x value as 2 plus t. The y value is 3 minus 3t. The z value is minus 1 and minus 5t. Correct? So that is a point in general. We can say this is the point M. Now, slope of this P to M is what? So slope, or the direction we should say, P to M. So we should use the word direction, not slope, in vectors. So let's say D, direction from P to M is what, right? So either way you could write. So we have this point, and the point is 1 minus 3, 1. So we'll do 2 plus t minus 1, right? This is x value difference. Y value is 3 minus 3t. Minus minus becomes plus 3. And the z value is 1 minus 5t, and z value is minus 1. Okay, so that becomes the direction. Let's simplify this. So this direction of the line from P to M is t and plus 1. This is minus 3t. 3 plus 3 is plus 6. And here we have, is it, okay, so z point minus 1. This was minus 1 here, and minus 5t, right? So minus and minus, minus 2, and we have minus 5t. Correct. So that is what we have. So that is a point, that's the direction, and we know the direction of the line also. So dot product of this direction is 1 minus 3 minus 5, correct? So these two should be perpendicular, or we can say that the dot product between t plus 1 minus 3t plus 6 minus 2 minus 5t dot of the direction of the line, which is 1 minus 3 minus 5, should be equal to 0, right? So that is what we mean when we say perpendicular. So let's just do the dot product now. So we get t plus 1, and minus 3 makes it minus, minus becomes plus 90 minus 18, and here we get, sorry, plus, right? And minus 5 is plus 10, and minus 5 is plus 25t equals to 0. So now let's add the terms here. So as far as the t values are concerned, coefficients, let's add them. This is only 18, not t. Okay, so t will have 3. These are the 3 values. So 10 and 25 is 35. So we have 35t. And the constants 1 and 10, 11. When you take away, then we get, when you take away 11 from here, we get 7. Minus 70 equals to 0. So that's what we get. It's not 70, but a constant 7, correct. So that gives you that the t value is basically 7 by 35, or 1 over 5. So that is the value of t in this particular case, correct? So that's what we get. Now we can find what the point is by substituting t in this particular expression. So let's do that. So we have the x value as equal to 2 plus 1 over 5, right? So because t is 1 over 5. So that is 10 and 1, 11 over 5. Y value is 3 minus 3 times this, so minus 3 over 5. 15 minus 3 is 12, 12 over 5. And the z value will be minus 1 minus 5 times, so 5 times 5 is reciprocal is 1, so minus 1, so which is minus 2. Correct? So we get our answer, and the answer here is that the point M, which is find the coordinates of the point that produces minimum distance. So the point for minimum distance will be, let's say, M in our case, which is 11 over 5 and 12 over 5 minus 2. Correct? So that becomes the answer for us. I hope the steps are absolutely clear. When we are talking about a line, we have the directions to consider. Perpendicular means that their dot product is 0. But when we are talking about the planes, we have the normal. So it is along the normal, and therefore we had this kind of scenario. So that is how we are actually going to solve all the three questions. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.